I'm John Landells for Equalum, and in this video I'm going to give you a walkthrough of the Equalum platform, show you some of the unique aspects of what we can achieve with Equalum, and let you see how it might benefit you in your organization. Let's dive in. So we're looking here at the Equalum dashboard. I'm not going to spend a lot of time today going into every single part of it, but I would like to show you a few different use cases that really gives you a feel for the platform and tells you a little bit about why Equalum's different. First thing I'd like to cover is what we call replication groups. The idea of a replication group is, let's say you have something like an Oracle application database, and you want to start running reports against that data, but you don't necessarily want to start doing lots and lots of BI against your application database because of the potential for the additional load on that database. So you want to replicate that data somewhere else. And for the purposes of this demo, I'm assuming here that we're going to go from Oracle to Postgres. If we have a look at how this has been built so far, you can see that I've selected my Oracle source. You can see that I've selected a Postgres target and specifically a database and schema within that. If we have a look here, I've already selected some of the tables. This is already configured, it's already running. But if I wanted to add more, I can very easily come in here. I can specify various different schemas. I can specify a pattern for the table name. And I can say, show me any tables that match. And I've now got two additional tables in here. I'm still going to adjust this. I'm going to get rid of that one, leaving me with one new table. I can go through here. I could customize this. Okay, so one of the things that I would usually do when I'm doing this kind of operation is I would configure end-to-end schema evolution. And you can set this as a default, but I haven't got it as a default on my system at the moment. This is just a demo platform. What end-to-end schema evolution does is it says, if your source database changes, okay, if the data definitions change, we'll automatically reflect that in the target. And in this kind of replication scenario, that's what we want. If we have a customer database and we add a field which might be alternate email address, we want that field to immediately appear in our target. We want to immediately start synchronizing that data. That might not be the case if you're building your flows by hand and you're doing lots of additional processing, enriching the data. Okay, you might be using fields for grouping or for sorting or filtering. And if you change your field, that field might not exist anymore. So this evolve stream option would allow you in those circumstances to simply receive a notification to say, hey, something's changed. Here's a draft of what we think you actually want it to be now, but you have to manually publish that draft. In the meantime, we'll simply cache the changes. So you're not going to lose the data, but for for replication, we want the end-to-end schema evolution. Okay, if I was to apply this, it would immediately start synchronizing for me. And what it actually does behind the scenes, it does it in a number of phases. The first thing is we do an initial capture read. So we're looking at that source and we're reading all of the historical data that's in there. Once we start doing that, we're able to create that target table and start populating it. So we have this initial capture right. So that historical data is immediately being moved across so that we can start running reports, we can start making business decisions, whatever we need to do. And we start caching the changes. Obviously, we don't push those changes until we've done the initial capture right. But as you can see, very quickly, we can get to this point where we can be synchronizing that data across. And this is useful in a number of situations. So first of all, as I mentioned, if you have an application database and you want to replicate the data to an analytics database or a data warehouse, something like that, that's one use case. What if you have an application that you're migrating to the cloud? So you've got it on-premise at the moment. Let's say it's running SQL Server on-premise. You want to move it to Azure and you want to run it under Azure SQL Server. We could do that migration of the data, but because the replication stays in place and we're synchronizing that data at all times, you have an opportunity to effectively run it in parallel, to keep some people on the old system, move beta testers maybe across to the new system, but you're still keeping all of that data from those original people, so that until you finally make that switch over to the cloud, your data is still being fed through and still in sync. The second use case that I want to talk about is actually something that's a little bit more traditional. You may have had tools in the past that did batch ETL for you. And there's still a place for batch ETL, even in a modern hybrid landscape. But you don't necessarily want to have sort of 3 or 4 different tools doing all of these different jobs for you. So we still allow you to manually build batch ETL jobs. We have one here where, if we have a look, I'm taking airport data. So this is details of airports, which includes here an airport code. And you can see some of these fields are null. I want to assume that if I push this all the way through to Snowflake, if there's any fields that are null, it's going to cause a problem in whatever I'm using that data for at the other end. Okay, so we want to mitigate this. First thing we need to do is to identify any row of data from the database that has a null in that column. And that's really easy to do. We simply have this split operator. We check if that field is null. And you can see if it is, we go to true. Otherwise, we go to not true. What this means is all of the data that we've got coming in here is only those records where that field is null. I can then very simply make some changes here. And for the purposes of the demo, we've kept it nice and simple. I'm simply writing in this city field. And to show you how easy it is to do that, if I double click city, there it is in my expression. So I'm doing that. I could do more with it. I could maybe do a substring. I could do a lookup to get this information from maybe another table somewhere. But whatever I do, once this is finished, the after situation here, you can see now my code is no longer null. Okay, that's how it was beforehand. That's after the transformation. Then I simply merge this data back together, and then it's ready to write out to Snowflake with none of these fields now being null. Okay, so this is a great situation where we would use a batch process rather than live streaming. We don't need this to be updated continually. We're not updating this effectively static metadata. We're not updating that on a regular basis. But maybe we want to run this once a week or once a month just to make sure everything's up to date. It's a perfect use case for batch. The final use case that I want to talk about is what we call streaming aggregation. So we're back to real time. In this case, we're bringing in an event stream of flight data. You can see that I have an ID, airline, an origin airport. You'll notice that this is JSON. We can very happily work with JSON or any sort of structured data in Equalum. We have a destination. We have how many stops the flight made and the price. I want to assume that what we actually want is not so much the individual flights, but a running total. How many were direct? How many were 1 stop? How many 2 stop? How many 3 stop? So what I'm doing here is I'm simply grouping all of my flights coming in by the number of stops. And I'm then aggregating this data and counting how many stops there were. That takes that constant stream of data and transforms it to this very simple set of data, which I'm here pushing out via Kafka. But this will be continually updated. So we'll have that streaming aggregation. At any point, I can look at this and I'll know the running total of how many flights were direct, for example. We can add windowing to this, so we can put a time window on here. So let's imagine this is sales data we're talking about. Maybe before we went to the cloud, before we went to a streaming solution, we had an end of month sales report that would run. So a batch ETL process that would collate all of that data and look at all of our totals. But imagine somebody on Instagram, an influencer on Instagram, had posted that they'd just found this great bargain, and suddenly there'd been a run on it. And within the first few days of the month, you were sold out. But you didn't know until the end of the month when you ran your batch ETL. With this, if I added windowing, I could get my running totals for the last hour. So I could see in the last hour, suddenly this particular product has spiked. So I can respond to that within an hour of it spiking, rather than at the start of the following month. So this is something that's hugely powerful, and it's one of the things that we believe is unique to Equalum. Thanks for watching. If you have any questions, or if you'd like to reach out to have a demo provided to you, maybe in more detail about specific issues that you have, please get in touch with us via our website, equalum.io. Thanks, and I'll see you in the next video.